All right, good afternoon. Today we're going to be looking at calling a API function that you cannot call in DataFlex. So let's get started. So today's example is to calculate the screen dimensions for all your monitors combined. So the API function that we'll be looking at is called EnumDisplayMonitors. This particular function requires something that DataFlex cannot do. It's called a callback function. Now, before you jump up and down saying that, oh, DataFlex supports callback function, it does support callback function, but not in a way that the Windows API expects. The Windows API expects a pointer to a function, which DataFlex does not support. You might say, what about refproc or reffunc, that kind of stuff? Those are not actual address of the function. That's just the message itself. So let's get started. So just like last time, if you didn't watch the video from last time, I'll put the link first thing in the description. So we're gonna create a C++ Windows library and choose a DLL. Okay. So let's just call it screen. Let's just call it screen. Okay. So that's the name of the DLL. So I'm gonna go decently quick this time because assume that you watched the last video. So extern C bool. Let's just call it screen sizes. Now remember to do Win API because you do want Windows calling or the Pascal calling convention. We are going to get a rectangle from you, and then we're going to initialize it. So let's save some typing. So I did type something out. So what I'm doing at this moment is that in DataFlex you're going to pass me a rectangle, and then I'm going to fill it up with 1, 2, and 3, and 4. So let's do that. Pragma comments linker export. All right, we do have one parameter, so we will have to do this. Now again, if you don't know what I'm doing, please watch the video from last time. It's not that long. So you have one parameter. Each parameter is 4 bytes. So when we compile this with debug build, we're going to create a function that will return 1, 2, 3, and 4. And then we're going to see how we get it back from DataFlex. All right. So in this example, we actually create a DLL right there. So we're just going to go to that particular place and create a program, DataFlex program right here. We're just going to call it test.slc. So why not? We're gonna take a look at test.slc to see what's going on. So use Windows external function. So let's take a look at what we called it. So the DLL itself is called screen.dll. The function is called screen sizes. All right, so screen.dll, and it expects a pointer and then returns a boolean. So what we're gonna do is to create a dummy function so that everything is a local variable. I don't usually mess with global variables too often because DataFlex is not really reliable when it comes to global functions or global variables. Let's see, twinrect. So we do have a structure like that defined. If you don't know where it is, it's in twinstructs.pkg. So basically this guy. So basically exactly the same as what you see in the Windows API. All right, so we got this, and then now this is because it's a struct, it's automatically initialized. So remember last time I said that whenever you pass a parameter to Windows API call, you better initialize it. But this line initialized it already. Whenever it's a struct, it will get initialized. So we're going to define a Boolean, and we're going to call this screen sizes. And then we're going to pass it of address of rect to success. And then we're going to stop it. We're going to take a look at the information here. All right. So we're going to run this program, and hopefully it compiles, and then you see this. All right. So let's take a look at what's rect at the end. So we're going to attach the debugger to the program, and we're going to pause. And hopefully we'll jump right to where the function call is at. So let's go to start. All right. So we are here. Let's put a breakpoint on line number 10, and then execute. Now, when I get to this, rect should return 1, 2, 3, and 4 as expected. Okay, so because we initialized it 1, 2, 3, and 4 right here. Okay, so now it's not a big deal. Obviously, you pass me some struct, and I fill in the struct. That's not what we want to do, but this is just to show you how to pass information back to your DataFlex function. All right. So what we want to do is to call a API. It's called EnumDisplayMonitors. Okay. So this function, once you call it, you will have to provide a callback function first. So as you can see that it asks for DC, so we don't have a device context. That's what DC stands for. Clipping rectangle, don't worry about this. I'm gonna put a no, and I'm just gonna call it monitor callback. So we're gonna define it, and at the moment we don't know what we're passing, so we're gonna pass 0. Okay. So now if you look back to the official documentation, it is expecting some kind of monitor enumproc thing. So you might be asking, what is that? Let's take a look at it. So monitor enumproc. So the function EnumDisplayMonitors is expecting a function pointer. So it's expecting a function pointer that looks like this. So we're going to copy this function prototype, and then we're going to put it back here. Now you don't have to call it exactly the name that they want. In fact, I will call it monitor callback. You don't have to call it monitor enumproc. You can call it anything you want. Now remember, this is the tricky part. Make sure that you have Win API here. I don't know why the documentation doesn't say it. Just assume that you know. So the name of the parameters are not important, but I'm gonna give it some name, clipping rectangle, and then let's just call it LP. Now obviously this is a Boolean function, return true or false. So the documentation says that if you want to keep on enumerating, you return true. So that's what we're gonna do. So now the question is, let's just say that you have 2 monitors attached to your computer. The moment that you call this function is gonna be called twice because you have 2 monitors, and then it's gonna return the control to line number 19. So the execution is number 18, and then line number 4 execute a couple times, and then hit back number 19. So obviously the function is going to get called, and then we have to extract information from this function and pass it back to here. So how do we do that? At the beginning, we can pass a integer or unsigned integer here, but you don't have to actually pass an integer. You can pass a pointer if you want. So that's exactly what we're going to do. We're going to pass in the LP rect. Okay, so I'm going to move the initialization code up. I'm just going to initialize it to 0. Right. Now you see a red line over there. It's because it's expecting a integer, but you're passing a pointer. So what are you going to do? It's expecting lparam. So we're going to just cast it to lparam, and you're fine. Now the reason why it's fine is that lparam is 4 bytes. an LP rectangle is a pointer to a rectangle, it is 4 bytes. So as long as the size match, you're fine. So now when it comes to this particular function, this is basically your LP rect. So what I'm going to do is that to basically take it back. LP rect and RECT asterisk is the exact same thing. Just it's just a convention how you want to type it. So I'm going to typecast it back to a rectangle. Then I am going to call a function called getMonitorInfo. So what this is that it expects a monitor, which we do have because it passes a monitor to us. So I can pass in a handle to a monitor and then expect something, a pointer to monitor info. So we're going to define a monitor info. We're just going to call it info. We're going to pass the pointer to it. In C++, you pass in ampersand. In DataFlex, you pass in address of. Info, you have to initialize it before you pass. You can just type in size of. It's like a size of type or size of struct in DataFlex. Okay, and so we're gonna do some lines here. I've typed up some lines. I don't want to bore you with the details. So what I'm doing is this, saying that if I find if the monitor that it is analyzing at this moment, if the dimension of the monitor is less than the rectangle that we derived, then on the left, then we're going to grab the monitor's left. Same as right, but this is bigger. So pay attention, this is less than, greater than, less than, greater than. So basically, we're just combining all the rectangles together to get the dimension. Assuming that you have 2 monitors side by side, then you will actually get the full size of the entire monitor. If you have 4 monitors, 3 monitors, it will get the outer rectangle for everything combined. Okay, so so having said that, let's take a look at if that function works. So this is a pretty simple function. We just, whenever we are called here, we get a handle to the monitor, and then we call another API function to find out what that monitor, what kind of dimension it has. So within it, there's a rectangle called RC monitor that contains the left, right, top, bottom. So we're just gonna compare it based on this. Okay, so we're gonna build this. So it cannot build because our program has not stopped. The DLL is still getting used. All right, so let's start again, build it. So everything is good. You see that the new DLL is getting output here. And let's go back to our program. So we're gonna run this. It's finished running. And let's debug it just to make sure that it gets the dimension correctly. All right, put a breakpoint right there and F5. Click OK. As you can see, the rect contains the dimension that we want. Right now I have a single monitor, 1600 by 900, but if you have multiple monitors, this function is going to grab all the monitors, combine all the coordinates and then or dimensions, and then give you the overall dimension. So if you have 2 monitors like this, it's going to be 3200 and 900, given that you're doing it side by side. So if you have a top-down arrangement, then it's going to be 1600 and 1800, so on and so forth. All right, so that's it for the tutorial. I will see you guys next time.